Hello, welcome back to the data channel. So today in this video, we are going to cover one of the very important topic that is normalization versus denormalization. So this is a complete guide I would consider where I'll be explaining the concept, benefit, drawback, and also we'll take a real world case study, right? And understand what exactly the difference between normalization and denormalization and what are the pros and cons of this individual ones, and whether you are a data engineer or whether you are data model, you are working on a database data modeling, okay, or as an architect. So this concept is pretty much important. So this seems simple, but most of the understanding about data models and how do we design when it comes to the system design kind of concept. So this becomes very important to understand, right? So whether you're preparing for an interview or just want to have a strong understanding of how databases are designed, so that will be a completely understanding because we have the uh, ca- case study at the end of this video. Please follow this video till end of this so that you will get maximum out of this video. So let's get started. So let's start with normalization. So normalization is basically the process of organizing the data in database to reduce the redundancy and improve the data integrity. So the key word here is reducing the redundancy, that is minimize the redundancy, and also to improve the data integrity. Right, in simple words, we can split a large table. Basically, there will be large table into smaller ones. So it might be hierarchical. That means one table can be split into another table, and that table again can be split into multiple tables. It can be like hierarchical, or it can be like just one table is splitting into multiple tables. And basically, it's not just about splitting. We need to have that relationship intact, whether it is a primary key, foreign key. After we split the main table into multiple child tables, so the primary key and foreign key actually connects them, right? For example, instead of storing the department name along with every student, so we just store the department ID in the student table and keep a separate table for department. So this way, no data is repeated, right? So that's the advantage of normalization. The major objective of normalization. So basically, the main motive of doing normalization is to remove the redundancy, avoid anomalies, and also ensure the consistency. Because consistency is important, because normalization will come, we will understand why it is used in OLTP systems, etc. But so basically, in OLTP systems where normalization is used, so there actually the consistency is ensuring consistency is very critical because of the reason because of there is a lot of read write operations will be happening. So coming to the main benefits of normalization, so basically it saves storage, because as you saw, like, you are just eliminating the duplicate records, and also it ensures the consistency and integrity, and it makes updates and inserts very efficient. So it doesn't create any duplications, right? Like, so duplications it will not create. And also, if the data is in particular table, and it also update all the respective dependent tables, right? So that is how you keep that consistency, integrity, and also makes updates and inserts more efficient, and it avoids any anomalies like update, inserts, and delete anomalies. So basically, when you what is anomalies, like insert, update, delete anomalies are nothing but when you are performing these operations, it can make the data inconsistent, right? So that kind of thing it will avoid. And also there are some drawbacks, like there is a catch, right, with the normalization, using normalization. So that means when you're using normalization, means you're having more tables, which means you need to have more joins in the queries. So this can make queries slower and not so great for reporting or analytics. So this is majorly about benefits and disadvantages of normalization. And if we take an example here, so you have a student table, and you see here there is a department name called CSCSEC. So basically, instead of repeating this record, what we do is we kind of create a separate department table, and we give the department ID here. Actually, it's 101 and 102, right? And then you kind of refer that instead of department name, you are referring the key here. Okay. So because of that, it is actually removing the duplication. It might feel like you are adding more data here, but it is not. Because think of it, here it is just a small table, but think of it, you are having millions of records, millions of billions of records. So then like storing the string values or description values can hold a lot of memory. So the memory is stored here, the memory is saved here basically, and also you are avoiding the duplication of the data. Okay, so which is the main intention of this. So now let's talk about denormalization. Denormalization is opposite. That means it is here we introduce the redundancy in the database to improve the performance. So why we do that, that we will see. Instead of splitting everything into smaller tables, we combine data as much as possible. So the queries runs faster because when you combine the data, there is you are actually avoiding the joins, or you are minimizing the joins. So basically, and here the purpose of denormalization is to make faster reads, simplified queries, and optimize the reporting. Okay, so keep these words in mind, because we will see which scenarios this kind of use cases will come, or requirement will come. Okay, so this is a denormalization, what it means. And quickly, if you see what are the benefits and disadvantages. So benefits are like definitely you will have lesser joins, fewer joins, which means you have faster select queries. So it is better for reporting and analytics, and queries become simpler to write as well, right? And there are a few drawbacks. That means it handles data gets duplicated. So that is one of the drawback, and it's okay to have this because we know it data is duplicated here, and more storage is required. So even like in terms of storage, because the data is getting duplicated, we need more storage. Even that is fine, because this particular denormalization we generally use in OLAP systems, which are having a cheaper storage systems compared to the database systems, which are OLTP systems. So that is why it is okay to have these disadvantages, but keep in mind these are the disadvantages. And also, like, updates and inserts can lead to inconsistent anomalies, but generally we don't perform updates and inserts here, because when your intention is to denormalize the data, it is mostly in the OLAP cases. So that we will definitely discuss. So keep in mind when you're talking about normalization and denormalization, so definitely you need to remember in your back of mind, we're talking about OLAP and OLTP systems. Okay, that we will come to know. But keep in mind, when you're talking about denormalization, you're talking about OLAP. Normalization, you're talking about OLTP. So if you understand OLTP and OLAP, what is the requirement, what these systems are built for, so then you can quickly understand where normalization fits and where denormalization fits actually, right? So moving on, so if you see the example here, basically we are denormalizing. That means you are merging the attributes that are possible attributes here, and keeping department name also in the same table. So instead of separating it in a different table, right? Now let's see the key difference. So normalization reduces the redundancy, denormalization increases the redundancy. That is we've already seen. Normalization ensures integrity, denormalization improves the query speed. So that's the key here. So there's always a trade-off between the query speed and also the integrity. So when you need a good query speed, so you cannot sometimes you cannot guarantee the data integrity, and you can have some anomalies like delete update anomalies. When you normalization is best for OLTP systems. So that's what I was just saying, right? When you are having a OLTP systems, like for example, transaction application, like banking application, retail, e-commerce application. So in that case, you definitely go for OLTP because you are having a lot of inserts, updates, delete operations are continuously happening there. And in case of OLAP, right? OLAP, what happens is like where you have a reporting and analytics use cases. So then you basically denormalize the data because here the performance is important. The query performance or the read performance is important because you're performing the analytics based on the huge volume of the data. And the performance is important. That means you are plugging these queries to the dashboards or reports for the leadership and the end users. So the performance of these reports, whenever they are refreshing or whenever it is scheduled, it should be near real time or real time. So that is the expectation. So that is why you basically need to avoid the joins and keep the data in one table or a minimal number of tables. So that is why you prefer denormalization in OLAP systems. And yeah, so definitely denormalization needs more space and normalization needs relatively less space. And denormalization is best for cases where you have faster read queries and normalization is for slower read queries. And complexity wise, normalization as a data modeler or even the programmer, so it is more tables. That means you have more relationships, right? And so here it is fewer tables and joins will also, or the queries also will be simpler. So this slide, the main point is OLTP and OLAP. So if you understand why this OLAP fits into denormalization scenario and why OLTP in terms of normalization scenario, so you understood the concept, right? So that is the key point here. So now, like it should be by now, it should be easy to guess when to use which. That means when to go for normalization and when for denormalization. So when it's a OLTP and example banking, e-commerce transaction applications, when there are a lot of write operations happening, insert, update, deletes are very frequently happening. So data integrity is critical. So in this scenario, go for normalization, and when it is OLAP system like data warehouse, business intelligence, dashboards, analytics, you have a read heavy query. That means you are performing a lot of joins, aggregations, and plugging into dashboards and reporting. So in that cases, and the performance is very important here rather than the data integrity. So in that case, you choose denormalization. So with that, we will take very basic examples here. Like OLTP systems are like highly normalized that we already saw and ensures there is no duplicate customer ID, customer balances, because you cannot have you cannot afford to have duplicated customer balances because that can create a lot of data integrity issues, right? If balance is updated to one place and it is not updated in other place, so that would create an issue. So then this is a case where we talk about OLTP, that is banking system, and OLAP is where we're talking about reporting, that is generally in case of data warehouse. So basically OLTPs are like the where you pull the data from, right? And OLAP is where you make the reports and dashboards. You create a reports and dashboards based on the data you get from OLTP systems. So this is where you denormalize the data which you got from OLTP systems generally and keep them pre-aggregated. So you pre-aggregate the values, customer plus account information in one place for faster reporting. So this is the real world example. In you can replace this OLTP here. We are taking banking system. You can take it e-commerce, retail, logistics, banking. Like banking is already here, so you can take any other OLTP system like transaction systems. So that will fit into this. So next, so this is important, right? So when you are appearing for an interview or when you're discussing design patterns or system design kind of a thing, so this kind of questions comes into picture where like whoever you want to understand the interviewer or the other person who want to assess you want to understand what exactly you understand from the level of system design, right? So they, I mean, the expectation here is to come up with how you take a scenario of or a case study, and the expectation from system design perspective is to understand how exactly your thought process is when you want to normalize or denormalize the tables or data sets that you have, right? So let's take this problem statement. You have a large e-commerce system company that wants to build a robust operation system to manage day-to-day orders and reporting analytics system to drive business insights. So the OLTP systems will be used for transactions, customer placing an order, making payments, etc. And the OLAP system will be used for business roles, sales reports, customer segregation, profit analysis, etc. So the challenge here is OLTP requires normalization for integrity, while OLAP requires denormalization for faster analysis. So this is anyway the problem statement, right? So how do you design the system, right? So that's the question. So you understood it's an e-commerce system. So you start thinking of the number of tables that you might have in the e-commerce side, right? And we will have to consider both the cases here. The system should the end-to-end project that you are building should support both OLTP scenarios and OLAP scenarios. That means it is a hybrid approach, right? You have to follow. So now, so the step one is basically you need to identify the core entities. What is entities? It's nothing but the number of tables that you might have, right? So from the domain analysis, we identify the following main entities. So because as a domain expert or like as a e-commerce, this is a project, right? You can understand there will be a generally customer table, product, order item, payment, shipment, category. So these are the very common entities. So we need to identify. This is the first step where you identify these uh, entities. The second step is normalize data. So this is for OLTP. So you need to normalize the data as much as possible. That means you split the data in such a way that each entities are representing the granular level of details. Like suppose um, we have identified the tables here, right? Around 5 tables, and again we are splitting into multiple tables here, around 8 tables, to make it as much as normalized. Okay, so even you can think of see when the address is normalized here, right? So address, customer address here, if you see address was not there, but you are splitting that address into a different table here. Okay, that's the important thing. Okay, so you can think of what more you can normalize. So you need to go to that granular level and normalize the data as much as possible, right? So basically, you can think of it like a snowflake design where you snowflake model, data model, where you kind of go to the least or maximum to the depth wherever you can perform. That means you are going to the third normal form. Okay, we design the tables with the third normal data for the data integrity. So if you are not sure about what are the different normal forms and what is the third normal form, so I will put link in the description of different normal forms. You can go through that, and also you can see on the top here. So there is a like link in the link that is you can click and you can understand what are the different normal forms. So now moving on to the step three, right? So step three would be basically to kind of concentrate about OLAP. So OLAP means you need to denormalize. That means you need to have a very less number of tables. So we are merging all the attributes from all of these tables into least minimum and making them into like fact and dimension tables. Ultimately, when it comes to the OLAP, it is more of a data warehouse. It becomes like a data warehouse scenario, right? Where you design a star schema for like a data warehouse. Okay, that means you don't have too many. You just have fact and dimension, and one generally you have very less fact tables and like a couple of dimension tables around it. Okay, so here you have one fact tables that is sales, and that is having supporting dimension tables like date, customer, product, etc. So, and why are we denormalizing here? Because the pre-joins, so you need to perform pre-join customer. So here you are having all the customer pre-joined data, right? The product category and all the dimension are in one table. and it reduces the join complexity at the time of querying. Okay, supports aggregations like you want to perform total sales by category per quarter. Okay, or you have a scenario where you want to understand profit by customer segment and region. So basically, you need not write a complex joins, whether you might be doing a join between one or two tables, or you get the information from even one table without any joins. So that is the whole intention here, because the more you perform the joins, so your analytics queries will go slow, right? So that's the reason. And now let's move to the step four. So step four is where simply mean that we need to take both the approaches. You cannot avoid normalization. Also, you cannot avoid the denormalization. So OLTP layer where it is normalized. You talk about MySQL, PostgreSQL, or SQL Server. Any of this, these are basically the like OLTP scenarios where the transaction systems or applications will be connected to, and they will be interacting, right? And there will be ETL layer to bring the data from OLTP to OLAP systems. That means load the data from databases to the data warehouse. So data warehouses are basically, it can be Snowflake, Redshift, Databricks, BigQuery, or Synapse Analytics, or Synapse data, Azure Synapse, etc. Can be any data warehouse system, right? So finally, we will see this quick example of OLTP. So OLTP, how many products did customer 101 buy last month? So if you are doing this, here you see we need to have a lot of joins. So to get this like a query answered, or to get the result for this query, I need to go from customer table, order ID table, orders table, order item table, right? So and perform a lot of operations here, okay, because the data is too much normalized and it is OLTP. But however, in OLTP, we will not come across writing such a complex queries, because OLTP is not meant for querying. Basically, it is meant for read-write operations. Basically, read-write operations. So when it comes to the like in OLAP, that is denormalized, the data will be completely denormalized. Talk about sales revenue by category and month. So you are just connecting the fact table with one or two dimension tables, and you're performing you're getting the results here, right? So here basically the query is fast, because due to there is a pre-joined dimension tables, the data will be relatively faster. So with that, we come to end of this video. Basically, before concluding, I would like to add few points here. So there is nothing called as there is no thumb of rule that you have to choose normalization, you have to choose denormalization in OLAP, OLTP systems. Like these are the best approaches. That is in terms of OLTP transaction systems, you choose a normalization, but in terms of OLTP system, OLAP systems, you try to keep the data denormalized. But it is not a thumb of rule. So these completely based on the workloads and the scenarios and the memory that you have, and what are the use cases that you are performing, whether you're performing data science use cases or just analysis or analytics use cases. So it depends on a lot of factors. So there is no thumb of rule. And also, if you design a data model at the start, it doesn't mean that till end of the project, so the same data model will continue. So you need to adjust the models, you need to fine tune the models, like it will be live design. So you have to play around with that. And OLTP must prioritize the correctness. That means it concentrate about the integrity part of it. And OLAP must also always prioritize on the speed. So this is very critical. OLAP doesn't compromise on the performance, because the queries need to run very faster and get the results. OLTP, the main intention is to have the data integrity in place and avoid the duplications. And the hybrid design always works the best. So normalize in source and denormalize during reporting. That's the best case. And always we bring the data from ETL, I mean using ETL or ELT pipelines, we bridge the OLAP and OLTP systems, right? And that means we bring the normalized data and then denormalize that using the star kind of a schema or a data model. So it is always a trade-off. Like every decision should be aligned with the business goals, right? Whether you want to have a transaction safety, that means integrity, or a reporting speed. So there is always a trade-off you need to think of, and like you need to decide which one to go in a particular scenarios, right? So this is all about it. Hope this was useful. If it is useful, please share with your friends, and also please subscribe to this channel and comment if any questions in the comment section. Thanks for watching.